Okay, we finished with the relationship between critical constants PC, VC, and TC, and between van der Waals constants A and B. So VC is equals to 3B, PC is equals to A by 27B square, and TC is equals to 8A by 27RB. Next, we will move on to an important concept, that is application oriented concept, liquefaction of gases. So, for important commercial operations such as LPG and rocket fuels, we require gases in their liquid state. The liquefaction methods are based on Joule-Thomson effect. What is this Joule-Thomson effect? This is a phenomena, of lowering of temperature when a gas is made to expand adiabatically. So this is a phenomenon that happens where lowering of temperature takes place when the gas is made to expand adiabatically. So when a gas expands, there will be lowering of temperature. It happens. From a region of higher pressure into a region of lower pressure is known as Joule-Thomson effect, which is an important 2 or 3 mark question. Right? So what is Joule-Thomson effect? This is a phenomenon of lowering of temperature when a gas is made to expand adiabatically from a region of high pressure into a region of low pressure is known as Joule-Thomson effect. Right? Next one, the inversion temperature. Why learning about all these? Because based on these temperatures and based on these critical constants and based on Joule-Thomson effect only, we will be able to liquefy gases. Right? So here Joule-Thomson effect is observed only below a certain temperature. Aதாவது, what is Joule-Thomson? Lowering of temperature happens when a gas is made to expand adiabatically from high to low pressure region. So the Joule-Thomson effect, where are we? Inversion temperature. Joule-Thomson effect is observed only below a certain temperature, which is a characteristic one for each gas. So for carbon dioxide, the inversion temperature is different. For nitrogen, it is different. For ammonia, it is different. Any gas, it is characteristic of each gas. This temperature below which a gas obeys Joule-Thomson effect is called inversion temperature. So what is inversion temperature? The say you have to write. The Joule-Thomson effect is observed only below a certain temperature, which is a characteristic one for each gases. This temperature below which a gas obeys Joule-Thomson effect is called inversion temperature. So how can you calculate the inversion temperature? Ti is equals to 2A by RB, where A and B are the van der Waals constant. Gases like, this is important, gases like oxygen, helium, nitrogen, hydrogen have very low critical temperature. Hence Joule-Thomson effect can be applied for cooling effectively. At the inversion temperature, no rise or fall in temperature of a gas occurs while expanding. At inversion temperature, no rise or fall in temperature of a gas occurs while expanding. But above this inversion temperature, the gas gets heated up when allowed to expand through a hole. இது give reason கேட்கலாம். They will ask and give reason why above the inversion temperature gases gets heated up. At inversion temperature there is no rise or fall in temperature of a gas. It occurs while expanding. So but above the inversion temperature the gas gets heated up when allowed to expand through a hole. So there are different methods for the liquefaction of gases: Lenz's method, Claude's process, and adiabatic process. So first is Lenz's method. Here Joule-Thomson effect is used to get liquid air or any other gases. It is actually a big process, but they have cut short all those experiments and gave it as a method. Next Claude's process. The gas is allowed to perform mechanical work. This is important. Lin's method, Claude's method. Claude's method la வந்து perform, the gas is allowed to perform mechanical work in addition to Joule-Thomson effect, so that more cooling is produced. So Lin's la Joule-Thomson effect லியும் cooling தான் நமக்கு நடக்குது. ஆனால் மெக்கானிக்கல் ஒர்க்கில் எக்ஸ்பான்ஷன், மெக்கானிக்கல் ஒர்க் ஆஃப் எக்ஸ்பான்ஷன் happens in Claude's process. So already there is Joule-Thomson effect and mechanical work of expansion is happening. So cooling, so more cooling happens here. The last one, the adiabatic process. This is a cooling. In this process, cooling is produced by removing the magnetic property of magnetic material. அதாவது எந்த substance they want to cool அதை சுத்திலும் they will surround it with a magnetic material such as gadolinium sulfate. Gadolinium sulfate. Okay, they will pass magnetic current. Magnetic field அனுப்பும்போது all the materials will aligned in one direction. ஒரு directionல அது align ஆகி அப்படியே vibrate ஆகிட்டே இருக்கும். Suddenly they will stop the magnetic field. அப்போ stop பண்ணாங்கன்னா disorientation happens. Disorientation and different sizes or alignment வந்து it gets disturbed. அப்போ என்ன ஆகும்? Expansion happens and cooling happens. By this method, a temperature of 10 to the power of minus 4 அப்படின்னா என்னது 1 by 10,000 Kelvin, that is as low as 0 Kelvin can be achieved. So summary, what all we studied: Boyle's law, expression, condition and expression for two different states; Charles law, Gay-Lussac's law, combined gas laws, Avogadro hypothesis, Dalton's law of partial pressure, Graham's law of diffusion and effusion we saw. So with this lesson is over.